All right, so now we're going to look at one and two-way ANOVAs. Now for this one, this is not going to be a video where there's a calculator. We can make a calculator for a one and two-way ANOVA, but basically what we're just going to do is look at how to use the analysis tool pack again in a little bit more depth. It is a lot more work to make the calculator for one and two-way ANOVAs. So that's going to be a really, if you don't have the analysis tool pack, that's going to be a hard process, but we can do it. If you do have analysis tool pack, this is the video you're going to want to watch. So we'll talk about one-way ANOVA. It's also called a single factor ANOVA. It's basically like a t-test with a third group or a fourth or fifth group or whatever. It's the same type of data, use the same setup, and the only difference is that the p-value is just going to tell you that there is a significant difference somewhere in those three bars. Maybe bars 1 and 2 are different from one another, but 2 and 3 are not. What you have to do is you have to do something called simple comparisons to figure out where the difference actually lies. And the simple comparisons are just a bunch of t-tests comparing all of the different bars to each other. The p-value that you care about is the ANOVA p-value. It's going to tell you if there is a significant difference, and then you're going to do t-tests just to see where the difference actually is. If you're using something like SPSS, it will do the t-tests for you. If you're using Excel, you can just use the video prior to this to do a bunch of different t-tests. Okay. Let's keep going. So we're going to talk about two-way ANOVA really quickly. You know what? Let's not. We're going to talk about it after we look at the one-way ANOVA. So here's our one-way ANOVA. You can see that it's basically, like I was saying, it's the same kind of data that we had in the one-way ANOVA example. We've got two different species of barley here, and we're doing an independent samples t-test here to see if there's a difference between the two. Well, now we've added a third species. We can't do a t-test, but we can do an ANOVA. It's going to give us all of the same basic stuff. So click on Data, and then go to the Data Analysis tab. And then you're going to do ANOVA Single Factor. Click OK. Now, I actually think ANOVA is easier to set up because you don't have to do variable 1 and variable 2 and variable 3 and all that. You just take all of your data. Remember, grab the labels. One thing you do have to look at is it grouped in columns or rows? I always put mine in columns. The reason I do that is I've just decided that that's how I like my data to be set up. So I would suggest that you do that too, or you always set it up in rows. Either way, whatever. Just pick one that works for you and do it that way. Columns is the default, which is why I've decided, that I'm going to teach myself to do it always in columns. So if you want to make your life a lot easier, you could do kind of the same thing. So this is columns. You can see that species 1 is here, and all of the data for species 1 is in the column under species 1. A row would be, obviously you'd have your label over here, and then the data would move out this way. We need to tell Excel that we have labels in the first row. And I want to do an output range, just like with our previous videos. I'm going to go to cell F1 and click OK. And look, we're done, basically. Here's your output. What do we need from this? So the count, of course, we're just making sure that we've got the right number in there, the number that we're expecting. Here's our average. We'll need that. Clicked on File. Now we have to wait for Excel to do something. Anyway, you're going to need average for reporting your results. Variance, again, just like with our t-test, we need the variance because then we can compute the standard deviation. So we need these three here. Now you're also going to need your degrees of freedom, just like with t-test. But these degrees of freedom are a little different. These aren't exactly the degrees of freedom you've seen before. Usually degrees of freedom is df equals, let's say 19, or possibly df equals 38. This is for paired samples. This is for independent samples that we've did in the previous videos. In this case, df is going to equal to 57 inside of parentheses. So you need both of those degrees of freedom for this. You also need the f value. This is like the t value that we were getting in t-test, and you also, of course, need the p-value. This test is significant. This is saying that there is a significant difference between something in here. There's at least one bar that's significantly different from the others. If we look at the averages, and if we go back, we see that the p-value for the one sample t, or sorry, the independent sample t, is not significantly different. So 38.9, I guess 39, and 34 are not far enough apart to be significantly different. But 46 is far enough away to be statistically significant. So it looks like what's going on here is species 3 produces quite a bit more tons, this is tons, I guess, of barley than either species 1 or 2. So there's a significant difference here, and it's species 3 that is producing significantly more barley. Okay, so that's what you need. I'll show you in a different video how to write up the results. That might be something that you just bank for later, not necessarily something that you need for the homeworks that we're working on right now. So let's jump back here and talk about TwoWay ANOVA. This is also called a two-factor ANOVA, and it's going to add a whole new variable to the experiment. So if we had only been looking at the effect of diet, like let's say we have a large group of people, we're looking at, say, keto versus vegetarian diet versus you eat whatever you want, you just count calories. We're looking at how much weight all of these different people are losing and their overall health. What if we want to add in exercise as a different variable? That changes everything about the experiment, right? You can't just put in like as another column, like keto, vegetarian, counting calories, exercise, because it's not mutually exclusive, right? It's not like some people are just exercising and not on these diets. You could have a person on keto who exercises little. You can have a person who just counts calories but exercises a lot. So it is a completely different variable that we've added to the experiment. Here's one that is totally true. The one person or two ever in these classes who is from speech and hearing, you'll understand what we're talking about here. This is the example that I'm going to use. But before we talk about that, the additional variable is going to make it possible to have two different things we haven't talked about, which is a main effect and an interaction. A main effect is just basically the effect like from a one-way ANOVA. We can say, oh, there's more barley in group 1 or species 3. And you're going to have two main effects. You'd have, in our example of working out and diet, you'd have a main effect of diet. Which diet works better when you collapse across exercise? You'll have a main effect of exercise. Which exercise program works better when you collapse across diet? You'll also have an interaction, which is when one variable works differently because of the second variable, which could be counting calories works great. It's kind of a moderate effectiveness at all levels of working out. But if you're on keto and you work out a lot, then you see significantly different results. Maybe your overall health is better or worse, or, you know, who knows. I actually don't know anything about diets. So you fill in the blank with whatever makes sense to you. But as long as you're following my example, that's what I care about. Let's talk about voice pitch and age. This is a real thing that we can actually look at. This is in fact a graph here of actual vocal pitch for men and women at different ages. So what happens is, ignore these next two bullet points here. Just focus on this first one. Voice starts high until puberty. Then it drops really drastically. And then it continues to drop gradually before rising fairly quickly. That's what voice does. For men, anyway. So first what we've got here, we've just got a variable of time or age. So this is child, adolescence, adulthood, and elderly, or advanced age right here. So now we're going to add in sex as a difference. So now what happens is, yes, this is true for men, but for women, the voice is going to drop less drastically through puberty. It still drops a bit, but not nearly as much. Then it's going to continue on a gradual drop for women. And it doesn't have this fairly quick rise that it does for men. Well, what's going on here? It's the effect of testosterone on the vocal folds. During puberty, of course, for men, there's testosterone gets injected into the system, which causes the vocal cords to grow in size. At advanced age, testosterone is not produced in near the quantities that it was before. So what happens is the vocal folds begin to shrink. Older people, it's harder to tell if it's grandpa or grandma on the phone because their voices start to sound a little bit like one another. I shouldn't use grandpa or grandma because you kind of know their voices, but let's say you work at a call center and you have someone who is a grandparent age or older, great-grandparent, you may not be able to tell if it's male or female because the voices are beginning to converge in advanced age. And here's a graph that shows that. You can see that children are roughly in the same space. Then if male children are going to drop significantly. Female children don't. Here we are in adulthood. Drops gradually for women. Some different measurements of this will actually show that men continue to gradually drop a little bit until around 60, and then it starts to come back up. But this looks like it starts to come back up around 40, 45, something like that. Starts curving back up. So either way, you can see this curve starts coming back up. That does not happen for women. There is an interaction here. Age does not tell the whole story. Gender, or sex rather, does not tell the whole story. You need sex and age to describe what's going on with vocal pitch. And then for some reason over here, it looks like women's voices curve back up, but there's this one data point here that looks like the effect of an outlier. It shouldn't really do that, but anyway, so that's a two-way ANOVA. So let's go to Excel, and here I've got vocal pitch for children, both male and female, for adults, both male and female, and for the elderly, both male and female. So this is just as easy, since we're not making a calculator. All you got to do is go to Data, go to the Data Analysis tab. Now, you have two options here. You have two-factor with replication and two-factor without. If you have multiple data points coming down, you've got with replication. And I don't think I've ever used without replication myself. I've always got, multiple data points here. So let's just go with replication. We'll click on that. Our input range is going to be from A1, not B1, but A1, I know that this looks a little weird, but we've got labels here. We've also got labels here. So we have to select everything. So we're going to go from A1 all the way down, select everything. The whole gamut of data. Now it needs to know rows per sample. Well, I've got 20... 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. Okay, I've got 20. Yeah, that's what I thought. Good. Got 20 rows per sample. Our alpha is going to continue to be 0.05. And we're going to put it in output range. Again, we'll just do it in F1. And here you go. You've got a lot of stuff now. But this is everything you're going to need. So let's talk about what this is. If you look at this column right here, this is going to be everything that is, let's see, we're going to do some, this is everything that's male, and this is going to be everything female. Right, so you can see that we've got 20 observations for male children. So you can look at the average for male children, 274, the average for female children, 287. Then we can move to adult. The average for adult males, 131. The average for adult females, 236. Then we go to elderly. Elderly males, 181, and elderly females, 167. And then we've got total here. See that the count has changed to 60, so we're collapsing across age. And the average for men, for males, is 196, and for female is 233. That's your vocal pitch collapsing across age. Okay, so let's get rid of these colors. And then we can look across here. We've got, of course, everything for children is going across, male and female like we talked about, but then here's total. This is just an average for children is 275. An average for adults, doesn't matter what sex, is 186, and then an average for elderly is 177. Now, you might need those if you're reporting those, but what you definitely are going to need is this stuff right here. So here's our degrees of freedom. You're going to need that. You're going to need your F value, and you're going to need your P value. And it looks like we've got a significant P value for everything. There is, oh, that's one thing I wanted to show you. So every time Excel spits out sample and columns, and this is ridiculous to me. Columns here, you've got male and female, so this is going to be your variable for sex. And then sample, of course, is the other one, so it's going to be age. So I always rename those just so I know what I'm looking at. So we have a significant effect of age. Here's a sneeze. Sorry about that. We got a significant effect of age, and we've got a significant effect of sex. We've also got a significant interaction. And what does the significant interaction mean? Well, it is what I showed you here, that it changes. The story changes based on what age someone is and what sex someone is, right? We can graph this and take a look at that. So what I'm doing is I've clicked on this and dragged across. Then I'm holding down Control and clicking and dragging on these other averages here. And I'm going to Control C to copy those, and I'm going to paste values in this cell. I'm going to insert a cell here so I can put in some labels. And this is kind of what we're looking at here. So we've got female voices in orange and male voices in blue. They start at roughly the same place as children. As adults, males are, they've gone through a really drastic lowering of the voice. Female voices have gotten lower, but not nearly as drastic as males. And then in elderly, in advanced age, male voices are coming back up and female voices are continuing to get lower. This is what we mean when we say that there's an interaction. The lines are moving differently. The way the numbers change, the change happens in a different pattern. That's an interaction. Okay, so that's it. Good luck with your statistics homework, and I'll see you in the next video.